Minimum fuel equals trip fuel plus alternate fuel plus contingency fuel plus final reserve. The contingency fuel must be the greater of 5% of trip fuel or 3% of trip fuel where an en route alternate is available, or 5 minutes at the holding speed at 1500 feet above the destination aerodrome. For example, the trip fuel for a jet aeroplane to fly from the departure aerodrome to the destination aerodrome is 5,350 kilograms. Fuel consumption in holding mode is 6,000 kilograms per hour. The quantity of fuel which is needed to carry out one go-around and land at the alternate airfield is 4,380 kilograms. The destination aerodrome has a single runway. What is the minimum quantity of fuel which should be on board at takeoff? Well, the trip fuel is 5,350 multiplied by 5%, which is 267.5. Alternate fuel is 5 minutes at 6,000 gallon. Alternate fuel is 5 minutes at 6,000 kilograms per hour, which is 500 kilograms. The final reserve is 6,000 for 30 minutes, which is 3,000 kilograms. Minimum fuel is therefore 5,350 plus 4,380 plus 500 plus 3,000, totaling 13,230 kilograms. For a turbojet engine driven aeroplane, given taxi fuel of 600 kilograms, fuel flow for the cruise of 10,000 kilograms per hour, fuel flow for holding 8,000 kilograms per hour, alternate fuel of 10,200 kilograms, planned flight time to the destination of 6 hours, and a forecast visibility to the destination of 2,000 meters, what's the minimum ramp fuel? Well, the taxi is 600 kilograms. Trip fuel is 6 hours at 10,000 kilograms per hour, which is 60,000 kilograms. The contingency is 5% of trip fuel, or 5 minutes at holding speed, whichever is the higher. 5% of trip is 3,000 kilograms. The alternate fuel is 10,200 kilograms. The final reserve, 30 minutes holding, is half an hour at 8,000 kilograms per hour, which is 4,000 kilograms. And adding all these up results in 77,800 kilograms. The dry operating mass is 33,510 kilograms. Traffic load is 7,600 kilograms. Final reserve fuel is 983 kilograms. The alternate fuel is 1,100 kilograms. Contingency fuel is 102 kilograms. The estimated landing mass at the alternate, when calculated, is 42,195 kilograms. For a planned flight, the calculated fuel is as follows. Flight time 3 hours 6 minutes. The reserve fuel at any time should not be less than 30% of the remaining trip fuel. The taxi fuel is 8 kilograms and the block fuel is 118 kilograms. How much fuel should remain after 2 hours of flight time? As the flight progresses, trip fuel and reserve will both decrease. Assuming that at landing all the fuel is used, no trip fuel remains, therefore there's no reserve needed. The trip fuel at takeoff is 118 minus 8, which is 110 kilograms. That's minus the taxi fuel. 110 divided by 3 hours 6 minutes results in a fuel burn of 35.5 kilograms per hour. After 2 hours, this will be 2 multiplied by 35.5, which is 70. Subtract this from the 110 to get 39 kilograms. This is comprised of the remaining trip fuel plus 30%, i.e. 1.3. 39 divided by 1.3 equals 30 kilograms of trip fuel. Subtract this from the 39 kilograms of fuel at 2 hours, therefore 9 kilograms is the reserve. Another question on maintaining reserves. For a planned flight, the calculated fuel is as follows. Flight time 2 hours 42 minutes. Reserve fuel at any time should not be less than 30% of the remaining trip fuel. Taxi fuel is 9 kilograms, block fuel is 136 kilograms. That's the fuel on the stand, on the blocks, so to speak. How much fuel should remain after 2 hours of flight time? Well, the trip fuel will be 136 kilograms minus the taxi fuel, which is 127 kilograms. 127 divided by 2 hours 42 minutes results in the fuel burn of 47 kilograms per hour. After 2 hours, that will be 94 to be subtracted from 127, which will leave 33 kilograms. Divide this by 1.3 to find out the trip fuel of 25 kilograms. Subtract this 25 kilograms from the 33 kilograms to find out the amount of the reserve, 8 kilograms. Minimum planned takeoff fuel is 160 kilograms. 30% of the total reserve fuel is included. Assuming the ground speed on this trip is constant, when the aircraft has done half the distance, the remaining fuel is 70 kilograms. Is a diversion to a nearby alternate necessary? It was quite a simple calculation really. With 160 kilograms for the entire flight, and there's only 70 kilograms remaining halfway, a diversion would be necessary.